Here we have a question. In this question, we have to find the x and y component of Van's velocity and Van's acceleration at x equal to 50. As we can see here, the vertical direction and the horizontal direction. The equation in vertical direction, which is y equal to, is given in the terms of horizontal direction, which can be written as this. Now, here we have to find the component of Van's velocity in x direction and y direction at x equal to 50, and also we have to find the component of acceleration in x and y direction when x equal to 50 feet. So first of all, let's understand what's Van's velocity and what's Van's acceleration. So here, Van's velocity would be the differentiation of Van's position in y direction, where we can write Van's velocity in y direction is equal to differentiation of position in y direction with respect to time t. And for x component, we can write it as differentiation of x direction with respect to time t. And for acceleration, we can write differentiation of Van's velocity in y direction with respect to time t. And for acceleration in x direction, we can write it as differentiation of Van's velocity in x direction with respect to time t. So here, first of all, we will find the differentiation in y direction. As per the given question, we are given the velocity in x direction. So as we differentiate it, first we'll differentiate it with respect to x, and after that we'll differentiate dx with respect to time dt, and this is going to be our position. As we know, x is the position in x direction and dx by dt is the velocity in x direction. So now let's go with the question. As we can see, the equation of the motion is given and the distance at x equal to 50, the constant speed of van, which is 75 feet per second, is given to us. So the acceleration and the angle are shown in the figure, as we can see here. This is the angle theta. This would be the component ay. This is the component ax for the acceleration, and for this angle v, velocity, this would be component in upward direction, which is vy, and this would be the component vx. So let's go with the question. As we can see here, by simplifying this equation, we can write it as y equal to minus 0.0015 x square plus 15 feet. So taking the derivation with respect to time for x direction, vx can be written as dx by dt, where dx can be written as vx dt, where dx by dt is the velocity in x direction or rate of change of distance with respect to time in x direction. Also, here we can write acceleration in x direction as ax is equal to v dx d of vx by dt, which is x double dash, can be written as, where dvx by dt is acceleration in x direction. So as we know, v is constant, the velocity is constant as given in the question. It can be written as v equal to under root of vx square plus vy square. Going with the same for y component, the dy by dx can be written as, by deriving the equation, taking the derivative with respect to x, dy by dx is equal to minus 0.003 x. Now let's substitute the value in equation 2, as we can see here. From here we can get vy dt equal to minus 0.003x vx dt. From here we can write vy equal to minus of 0.003x vx, as dt gets cancelled out. From here we have a relation between y component and x component of velocity. Now we will substitute this vy in this equation number 2 and find the value of Vx, that comes out to be 74.2 feet per second, and from here we can get the value of Vy as 11.12 feet per second. Now we will do the same for finding the acceleration. We will take the derivation. We will differentiate this equation with respect to dx. On both sides we can write d Vy by dt equal to minus 0.003x into x dvx by dt and dx by dt into vx whole square, as we can see here. From here we can find a relation between ay and ax, as we can see. Now we will substitute the value at x equal to 50 in this equation, where the value of Vx comes out to be 74.2 feet. After substituting the value, we get relation between Ay and Ax, as you can see here. Ay equal to minus 0.15 Ax. In order to find the value of tan theta, we can write tan theta is equal to dy by dx. That comes out to be tan inverse dy by dx, where theta can be written as tan inverse minus 0.003 x. Now let's substitute the value of x as 50 and find the value of theta as minus 8.531. From here we can write ax cos theta minus ay sin theta equal to 0 as acceleration in xy direction. Now substituting the value of theta, we get the value of ay and ax as shown here. Value of ax comes out to be minus 2.42 feet per second and value of ay comes out to be minus 16.1 feet per second square. So we have found the value of x component of Van's velocity in x direction, where x equal to 50 feet is 74.2 feet per second, and the value of acceleration in x direction, that is 2.42 feet per second square. Value of velocity in y direction, which is 11.1 feet per second, and value of acceleration in y direction, that comes out to be 11.1 feet per second square. Thank